Dear students, today I am going to teach elementary analysis as a part of the course CH7102 Advanced Analytical Chemistry. Let me introduce myself to you. I am Prof.Vegi, Department of Chemistry, UDOM. Okay, first of all, we need to understand what is elementary analysis. That means the analysis of chemical analysis of elements where in any sample. For example, if you want to know the calcium amount of calcium present in milk sample, if you know, if you want to know the amount of calcium and magnesium present in water sample, or if you want to know iron present in blood sample, you will be able to analyze under by learning this chapter. So here under elementary analysis, we have three instruments: atomic absorption spectrometer, atomic emission spectrometer, and atomic fluorescence spectrometer. So in this concept, first of all, we are going to learn about introduction and principles. So what are the lesson objectives? So today's lesson objectives are outline the history of the development of these instruments. What are the instruments? Atomic absorption, atomic emission, and atomic fluorescence spectrometers. These three instruments are useful for the same purpose and they will work very similarly. That's why in this concept I am going to explain the principles of all the three instruments together, right? So what state the principle of working? That is another objective. By the end of the this lesson you will be able to understand the principles of working of these instruments. Explain the qualitative and quantitative principles. See, chemical analysis involves two parts: qualitative analysis and quantitative analysis. Quantitative analysis, by performing a particular chemical analysis, you will be able to know what are the elements present in a given sample. Okay, let us consider there are five elements present in a given sample. Now, the next question is what is the amount of first element? What is the amount of second element? What is the amount of third element? And determination of those amounts is a quantitative analysis. So by the end of this lesson you will be able to know how can you perform qualitative and quantitative analysis of different elements present in different samples. For this, in order to learn this chapter, you need to have notebook and pen. Right. Let me ask you a question. What is the mystery of poisoned water in the real world case? In the newspaper and in the TV channels, maybe you might have heard about water poisoning. What could be the reason for water poisoning? Light and atoms. The atoms and light are interacting, and after interacting, each element will show a particular color. What is the color code of elements? Visual demonstration required. So you need to show all these things to the in my next class. So guess the instrument that is useful for the purpose of above two. That means what is the instrument to know the poisoning of water, and what is the instrument that will have or that will study the interaction between atoms and the light. So guess the instrument and submit to me in the next class. Right. Now let me introduce the elementary analysis to you. In order to introduce the elementary analysis to you, first of all, I think you might have some knowledge about flame coloration test. Flame coloration test. What is flame coloration test? In the laboratory, we are having a particular test in order to determine a particular salt, whether it is calcium salt, sodium salt, magnesium salt, zinc salt, nickel salt. So the type of the salt can be determined by semi-qualitative analysis, that is called a flame coloration test. How will you do that one? You need to take a watch glass and take a particular unknown salt sample in the watch glass and add 2 or 3 drops of hydrochloric acid. After addition, you need to make a slurry of the salt by using a glass rod. After making a slurry of the salt, you need to take a pinch of that salt into and by using a glass rod and introducing to the flame. After introducing into the flame, if you observe, the flame color will change. Flame color will change. The flame color depends on the type of the salt. For example, if it is sodium salt, it will give you golden yellow color. If it is calcium salt, it will give the flame color brick red color. If it is nickel salt, it will give apple green color. So like this, different salts will give different colors to the flame. So based on the flame color, we will be able to identify which salt is it. But we faced a challenge in flame coloration test. For example, what is the challenge? In the case of calcium, strontium, and lithium, calcium, strontium, and lithium, they exhibit similar color to the flame, very similar, and our eye unable to distinguish that flame color is due to calcium salt or strontium salt or lithium salt. This challenge is enabled us to to manufacture instruments, and these instruments are atomic absorption spectrometer, atomic emission spectrometer, and atomic fluorescence spectrometer. What we will do with these instruments? We are recording the wavelengths of those colors from the flame. Based on the wavelength, we are identifying element, and subsequently we are able to quantify the element also. So now we are moving to the principles of these three instruments together. I am going to teach to you. Now let us consider this energy level diagram. We know the atoms are having energy levels, and let us consider these energy levels are E0, E1, E2, and E3. So when the elements are introduced into the flame, then the electrons present in the elements or atoms will get excited. For example, I can show you excitations here. E0 to E0 to E1, E0 to E2, E0 to E3. So during this excitation, they will absorb the radiation. Absorb the radiation. But the lifetime of electrons in the excited state is very, very minimal, very, very less. It is in the order of 10 to the power negative 10 seconds. And those electrons will come back to the ground state by emitting the same amount of energy which they absorbed. For example, if let me show it to you here. E1 to E0, E2 to E0, E3 to E0. So, for example, if the element is absorbing energy by a transition from E0 to E1, then the amount of absorbed energy or emitted energy is equivalent to the energy difference between these two energy levels. That means delta E is equal to E1 minus E naught. That is equal to H nu and Hc by lambda. So that means this emitted energy or absorbed energy is having a particular wavelength. This lambda is wavelength, and that wavelength is the one what we are recording by using these instruments. Now let me move to the further principles, particularly for qualitative analysis and quantitative analysis. For qualitative analysis, the wavelengths are very important. Each and every element has its own absorbed wavelength or emitted wavelength. So that means it is unique. It is unique wavelength which is absorbed by a particular element. So that is the basic principle for qualitative identification. Whereas for quantitative analysis, we are depending on Beer-Lambert's law. You can see this is Beer-Lambert's law. The absorbance is equal to logarithm of I naught over IT. That means incident energy over transmitted energy. That is equal to KL and naught. Here in this is very similar to Beer-Lambert's law, but applicable to atoms. So here N naught is the concentration of atoms in the flame, L is the path length to the flame, and K is the absorption coefficient. For example, here K and L are constant. When these two are constant, the absorbance is directly proportional to concentration of atoms in the flame. This is the basis for quantitative analysis. So let me summarize. For qualitative analysis, it is the specified wavelengths emitted by a given, absorbed or emitted by a given element. That is the basis for qualitative analysis. The absorbance is directly proportional to concentration of atoms in the flame. That is basis for quantitative analysis. So when you introduce sample to the flame, what happens? What kind of changes are taking place in the flame? So let me explain that one to you. You can see here in this slide, you can see a picture which shows how the sample solution is changing with different processes. You can see there is process called evaporation, vaporization, dissociation. So you are introducing a solution to the instrument, that may be atomic absorption, atomic emission, or atomic fluorescence. These three are working with very similar principles. I am going to explain to you the differences by using the same slide. Now, solution will be changed to mist. And this mist is nothing but aerosol. And then, after evaporation of this mist, it will remain with MX solid. That means salt in the form of solid. And this is present in the flame. And immediately it will undergo vaporization. That means MX is changing from solid to gas, and then it will undergo dissociation. After dissociation, you will be having individual atoms, M gaseous atom, X gaseous atom. So from here up to here, what happened? MX solution is changed to individual atoms, M gaseous atom and X gaseous atom. So this process of converting a solution to individual gaseous atoms is called as atomization. After atomization, we are having excitations. We have two types of excitations. Number one, thermal excitation. Number two, radiant excitation. Let me go to thermal excitation first of all. So you can see here, yeah, there is M gas and it is undergoing thermal excitation. After undergoing thermal excitation, it is M star. M star. And this M star, that means it is excited atom. And here it is thermal excitation. Where this thermal excitation is happening? It is because of the flame. Because of the flame. That flame temperature itself exciting M gas to M star. And also here, I already told you, the lifetime of any atom in the excited state is very, very less. And the atom will be relaxed or de-excited by emitting radiation. If you study or if you record that radiation, emitted radiation, that is atomic emission spectrometer. Okay. I am coming to another route, that means radiant excitation. So the atoms may undergo also radiant excitation. That means here you can see there is H nu. H nu means it is radiation. And after radiant excitation, so M becomes M star. When M is becoming M star, the element absorbs the radiation. If you study or record amount of absorbed radiation, that's what you are doing in atomic absorption spectrometer. You can see here atomic absorption, AAS means atomic absorption spectrometer. Now M became M star by what? By radiant excitation. Again, the lifetime of this atom is very, very less, and they emit that excess energy, that is called re-emission of radiation. If you study this re-emitted radiation, that is called as atomic fluorescence spectroscopy. So here we have three instruments: atomic emission spectrometer by thermal excitation, and by radiant excitation we have atomic absorption spectrometer during absorption, and re-emission of the same radiation if you study, that is atomic fluorescence spectrometer. So totally we are having three instruments. And what is the purpose of these three instruments? To analyze the elements present in any sample. That's why it is also called elementary analysis chapter. So I am giving you certain activities. You need to do these activities and submit it to me by tomorrow. What are those activities? Trace the evolution of atomic spectroscopy instruments. How these instruments are evolved. The complete process you need to give as a learning activity. And also what you understood about working principles of these instruments. And how do we apply these principles in order to get qualitative and quantitative analysis. You need to write down all these things on a notebook and submit it to me by tomorrow. So, based on today's lesson, I am going to give you also certain questions. So, you need to answer these questions. Trace the key historical developments that led to invention of AAS, AES, and AFS, three instruments. Draw and label a schematic diagram showing the main components of these three instruments. Briefly describe the role of each part of the instrument, each part of these three instruments. Of course, all the parts are very common, but there are little differences which you will be learning in the next session. Explain the qualitative and quantitative principles. And I have also one objective question. You need to answer this question and also submit it to me by tomorrow. This marks the end of this lesson. In the next session, you will learn more about the instrumentation of these three instruments: atomic absorption and atomic emission and atomic fluorescence spectroscopies. So I'm going to teach in the next class the general instrumentation for all these three instruments. And in the subsequent classes, I'm going to explain to you also each part of the instrument, how it functions and what are the parts of each, what are the different subparts of each part. All those things you will be able to learn in the next classes. Thank you very much. This is end of today's session.